Hello friends, welcome to HP Vibrant Academy. In this particular module, we will discuss about the gradient, divergence and curl. So under this module, we have to discuss these micro topics. Okay, so let us discuss this one by one. So first one is partial derivative of vector. Okay, suppose R is a vector. Okay, then we differentiate it. The partial derivative of vector is differentiation of R vector with respect to any of the variable x, y or z. Okay, so suppose we have to find the partial derivative of vector with respect to x, then it is del r upon del x. Okay, suppose r is a function of x, y and z. These are the scalar variables. X, y and z are scalar variable. Okay, so suppose we want to find the partial derivative of vector r with respect to x, so del r upon del x, then we have to differentiate this vector. Then we have to differentiate this vector with respect to x, keeping y and z as constant. This is the partial derivative of vector. So this we will discuss in detail. Okay, now we have to study about the vector differential operator. Okay, so this is represented, this is also known as nabla. This is represented as del. Okay, and this is a vector. This is represented as I del upon del x plus j del upon del y plus k del upon del z. This is a वेक्टर डिफरेंशियल ऑपरेटर. ओके, उसके बाद है अपना ग्रेडियंट ऑफ ए स्केलर फील्ड. ओके, सो ग्रेडियंट ऑलवेज अप्लाइज ऑन ए स्केलर फील्ड. ओके, सपोज एफ इज ए स्केलर फील्ड. स्केलर फील्ड. ओके, so del of f is a gradient. Del of f is gradient. Okay, and this del of f is a vector quantity. Vector quantity. Okay, so del operates on a scalar quantity. Okay, del operates on a scalar quantity and the result is del of f, that is a vector quantity. Vector quantity. Okay, after that we have to study these theorems. Gradient of sum of two scalar point functions, that is del of f plus g. Suppose there are two scalar point function f and g, then gradient of sum of two scalar point function is del f plus del of g. This is theorem 1. Gradient of a constant. So suppose f is a constant, f is a constant scalar point function, then del of f is equal to 0. Gradient of product of two scalar point function. Okay, del of, suppose two scalar point function are f and g, then the product of scalar point function is fg. Okay, so del of fg, so del of fg, del of fg, sorry, del of fg, this is gradient of product of two scalar point function. So this is equal to f del of g plus g del of f. And we have gradient of quotient of two scalar point function. How we can find this? So this is something like del of f upon g. This is equal to upon g square g del of f minus f del of g. Okay, this is gradient of quotient of two scalar point functions. After that, we have to discuss problems on the gradient, divergence of vector point function, definition of divergence. What is? We will discuss in detail about the divergence. There are some theorems on the divergence. What is definition of solenoidal vector? Definition of curl of a vector point function. Okay, so del cross f is a, suppose f is a vector point function, then del cross f is equal to curl. Okay, theorem on curl of vector point function, definition of irrotational vector, Laplacian operator, Laplace equation, and after that we have to discuss problems on the divergence and curl. So this is all about this module. We will discuss in detail about this in mm, this module. Okay, so let us start discussing. So first we have to discuss about the partial derivative of vector. Okay, so let us consider r is a vector. Okay, and it is depending on more than one variables. Okay, so let us suppose r is equal to f of x, y and z. Okay, and x, y and z are scalar variables. Okay, so r is a vector that is depending on more than one scalar variable. Okay, so the partial derivative of, how we can represent the partial derivative? So the partial derivative of r, suppose we want to find the partial derivative of r with respect to x. How we can define this? So the partial derivative of r with respect to x is represented as del r upon del x is equal to limit del x tends to 0 f of this is our um, function. Okay, so the r is a function of x, y, and z. So differential change in x, this is x plus del x y and z minus f of x, y, and z upon del x. Okay, so if this limit exists, then the partial derivative of r with respect to x is given by this particular expression. Okay, then del r upon del x is given by this particular expression. Okay, so we can say that del r upon del x is an ordinary 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 derivative of r with respect with respect to x, provided other variables y and z are constant. Okay, so for finding the partial derivative of r with respect to x, we differentiate r just like an ordinary derivative, keeping y and z as constant. Okay, so del r upon del y, so we differentiate r with respect to y, keeping x and z as constant, and del r upon del z, we differentiate r with respect to z, keeping x and y as constant. This is all about the partial derivative of vector. Okay, now let us understand few more concepts. Okay, so suppose we want to find del 2r upon del x square. So this we can write as del upon del x of del r upon del x. Okay, and del 2r upon del x del y. So this we can write as, the order of this is in this particular direction. So first we will write del r upon del x, and after that we have to differentiate it with respect to y. So del upon del y of del r upon del x. Similarly, del 2r upon del y del x. So this we can write as del upon del x of del r upon del y. Okay, so order is in this particular direction. So first we have to write del x. Now let us find total differential dr of r vector. Okay, so we have r is a function of x, y, and z. Then the total derivative dr is given as del f upon del x into dx plus del f upon del y into dy plus del f upon del z into dz. Okay, this is total differential of r vector. Okay, this is dr. Now we have vector differential operator. Okay, this is also known as nabla. So this is vector differential operator is represented at this. This is a vector quantity, and this is represented as I del upon del x plus j del upon del y plus k del upon del z. Okay, this is a vector differential operator, and it operates distributely. That is, it shows its presence in all the three directions, because in our term of nabla we have all the quantities, that is del upon del x, del upon del y, del upon del z. So it shows its presence in all the three directions, that is x, y, and z. Okay, okay, this is generally behaves like ordinary vector. Okay, and del upon del x, del upon del y, del upon del z can be treated as its components along I, j, and k. Now let us discuss about the gradient of a scalar field. Okay, let f, x, y, and z be defined defined and differentiable at each point x, y, z in a certain region of space. Okay, then gradient of f is defined as so we have del of f. Okay, so del of f is equal to I del upon del x plus j del upon del y plus k del upon del z into this function f. So this is equal to I del f upon del x plus j del f upon del y plus k del f upon del z. Okay, okay. So this is a del f, gradient of f is a vector whose three successive components are del f upon del x, del f upon del y, and del f upon del z. Okay, so the gradient of f always applies on a scalar point function. Okay, so f is a scalar point function, then nabla always applies on the scalar point function, and the result is a vector quantity. But in case of divergence, so this is divergence is applied on a vector point function, and the result is a scalar quantity. Okay, so if, let us write down in note here, if f is a scalar point function, then del of f is a vector point function. Okay, now let us discuss these theorems. Gradient of sum of two scalar point functions. Okay, so let us discuss one by one. This is theorem 1. This is gradient of sum of let us consider f and g as two scalar point functions. So this is gradient of f plus g. This is equal to del of f plus del of g. Okay, how we can prove this? So let us expand this. So we have I del upon del x plus j del upon del y plus k del upon del z of f plus g. Okay, so this is equal to I del upon del x of f plus g plus j del upon del y of f plus g plus k del upon del z of f plus g. Okay, so this is equal to I times of del f upon del x plus del g upon del x plus j times of del f upon del y plus del g upon del y plus k times of del f upon del z plus del g upon del z. So let us combine this. So we have this as, this is equal to I times of del f upon del x plus, sorry, let us take the term of f at one place. So this is I del f upon del x plus j del f upon del y plus k del f upon del z. So these terms we have written at one place, this one, and this one. Okay, plus I del g upon del x plus j del g upon del y plus k del g upon del z. This is equal to del of f plus del of g. Let us discuss gradient of a constant. Okay, ये कैसे करोगे? Theorem 2, gradient of a constant. The necessary and sufficient condition for a scalar point function to be a constant is del of f is equal to 0. So del of f is equal to 0 is the necessary and sufficient condition for a scalar point function to be a constant. Okay, so let us show this. Okay, so if f x y z is constant, then del f upon del x is equal to 0, del f upon del y is equal to 0, and del f upon del z is equal to 0. Then gradient of f is equal to I del f upon del x plus j del f upon del y plus k del f upon del z is equal to 0 I cap plus 0 j cap plus 0 k cap. This is equal to 0. Okay. Hence, so we have to show that the necessary and sufficient condition. Hence, the condition is necessary. Condition is necessary. Okay. Secondly, conversely, I will write down the theorem. Don't worry. Conversely, let gradient, other way around we are going. Gradient of f is equal to 0. Then I del f upon del x plus j del f upon del y plus k del f upon del z is equal to 0. So this means this is equal to 0 I cap plus 0 j cap plus 0 k cap. So here hence we can say del f upon del x is equal to 0, del f upon del y is equal to 0, and del f upon del z is equal to 0. Okay. Therefore, we can say that f must be independent of x, y and z. मतलब x, y, z से independent कब होगा? जब f is must be a constant. f constant होगा तभी तो वो independent होगा x, y, z से. तो f must be constant. Okay. Hence the condition is sufficient. Okay. So let us write down this theorem. So theorem 2. Let us write down the necessary and sufficient condition for a scalar point function to be constant is that del of f, that is gradient of f is equal to 0. This is necessary and sufficient condition. Now let us discuss the theorem 4, gradient of quotient of two scalar functions. Okay. Let us write down if f and g if f and g are two scalar point functions, then del of f upon g is equal to g square g del of f minus f del of g. ओके कैसे प्रूव करोगे इसको? कैसे करेंगे? So we have this, let us expand this. So I del upon del x plus j del upon del y plus k del upon del z of f upon g. Okay, so this is equal to I times of del upon del x of f upon g plus j times of del upon del y of f upon g plus k times of del upon del z of f upon g. Okay, तो इसको कैसे करेंगे? So this is equal to expansion of this is, let us expand this. So this is equal to g square into g del f upon del x minus f times of del g upon del x plus j times of g square g del f upon del y minus f of del g upon del y. Okay, similarly for this one. So on combining this, we will get this as g del of f minus f del of g upon g square. Okay, so this is all about the formula. So let us start discussing problems. So let us solve question number 1. So we have the expression for f as f is given as e to the power xy I cap plus x minus 2y j cap plus x into sin y k cap. Okay, so we have to find the partial derivative of f with respect to x. So we have already studied the concept of the partial derivative. Partial derivative is just like a ordinary derivative, but suppose we have a function. Suppose we have a function f. Suppose we have a function f uh, which is dependent on the variables x, y, and z. Okay, so suppose we want to find del f upon del x. Okay, so we differentiate f with respect to x, keeping y and z as constant. Okay, so del f upon del x is partial derivative of f with respect to x, keeping y and z as constant. Similarly, del f upon del y. Del f upon del y is partial derivative of f with respect to y, keeping x and z as constant. Okay, so let us use this concept. Okay, so in the first part we have to find del f upon del x. Okay, to del f upon del x, so we will take here f is a function of x and y. So for finding del f upon del x, we will take y as a constant. So let us find this. So we have this as the derivative of e to the power xy. So this is e to the power xy into derivative of xy. Okay, and y is constant, so this is y I cap plus j cap plus sin y k cap. Okay, in the second case we have to find del f upon del y. So this is equal to e to the power xy into differentiation of xy with respect to y. So this is x because x is constant. I cap plus this is x minus 2y. So differentiate this with respect to y, keeping x as constant. So this is minus 2 j cap plus x cos y k cap. Now in the third case we have to find del 2f upon del x square. This is equal to del upon del x of del f upon del x. Okay, so we have to differentiate del f upon del x again with respect to x. So this is equal to y times of e to the power xy into y square. Okay, plus j cap, there is constant 1 into j cap, so this is 0, and sin y, there is no term of x, so this is 0, so this is I cap. In the fourth case we have del 2f upon del x del y. Okay, so order is in this particular direction, so this we can write as del upon del y of del f upon del x. So del f upon del x is this one, so differentiate this with respect to y. So on differentiating this we have e to the power xy plus y into x times of e to the power xy I cap plus cos y k cap. So this is equal to 1 plus xy e to the power xy I cap plus cos y k cap. Okay, so now let us discuss question number 2, how we can find this. So we have the value of phi as phi is equal to xy square z and f is equal to xz I cap minus xy j cap plus plus yz square k cap. Okay, so let us find phi f, value of phi f. So multiply this with respect to xz, xy and 4yz square. Okay, so let us find this. So we have phi f, the value of phi f as this is x square y square z square I cap minus x square y cube z j cap plus x y cube z cube k cap. This is x y cube z cube k cap. Okay, so now we have to find, let us find del upon del x of phi f. This is equal to 2x y square z square I cap minus 2x y cube z j cap plus y cube z cube k cap. Now we have del upon del x square of phi f. This is equal to 2y square z square I cap minus 2y cube z j cap. Okay, now we have to find del square of del x square del z phi f. This is equal to del upon del z of del upon del x square phi f. Okay, so now we have to differentiate this with respect to z. So this is equal to 4y square z I cap minus 2y cube j cap. Now let us we have to find the value of this particular differential with respect to this point 2 minus 1 and 1. So let us place the coordinates here. So we have to find the value at 2 minus 1 at 1. 2 minus 1 and 1. So let us place the values of y and z in this particular expression. 2 minus 1 and 1. So this is equal to 4 into 1 into 1 I cap minus 2 into minus 1 का whole cube, तो minus 1 into j cap. So this is equal to 4 I cap plus 2 j cap. Let us discuss question number 3, how we can solve this. So we have the value of f as f is equal to 2x square y minus x4 into I cap plus e to the power xy minus y sin x j cap plus x square cos y k cap. Okay, so we have to verify that the del 2f upon del y del x is equal to del 2f upon del x del y. So del 2f upon del y del x, this we can write as del upon del x of differentiation of del f upon del y with respect to x. Okay, because we have the order in this particular direction. Similarly, del 2f upon del x del y is equal to del upon del y of del f upon del x. Okay, so first we have to find del f upon del y. So del f upon del y is the partial derivative of f with respect to y. So this is 2x square I cap plus this is x times of e to the power xy है ना, minus sin x j cap minus x square sin y k cap. Okay, this is now del upon del x. Differentiate this with respect to x. So del f upon del y. So this is equal to 4x I cap plus this is e to the power xy plus xy into e to the power xy minus cos x j cap minus 2x sin y k cap. So this is equal to 4x I cap plus 1 plus xy e to the power xy minus cos x j cap minus 2x sin y k cap. Okay, so this is the expression for del 2f upon del y del x. ठीक है, now let us find we have to find this one del 2f upon del x del y. Okay, del 2f upon del x del y is equal to del upon del y of partial derivative of del f upon del x with respect to x. So we have the value of f as is given as what is given in f. So f is equal to 2x square y. This is 2x square y minus x4 I cap plus e to the power xy minus y sin x j cap plus x square cos y k cap. Okay, let us find del f upon del x. This is equal to del f upon del x is 4xy minus 4x cube I cap plus this is y times this is y times of e to the power xy minus y cos x j cap plus 2x cos y k cap. Now differentiate this with respect to y. This is del f upon del x is equal to 4x I cap plus e to the power xy plus xy e to the power xy minus cos x j cap minus 2x sin y k cap. So this is equal to 4x I cap plus 1 plus xy e to the power xy minus cos x j cap minus 2x sin y k cap. This is the value of del 2f upon del x del y. ठीक है, so let us compare both the expressions. So we have this as 4x here. The coefficient of I cap is 4x. Similarly, 1 plus xy e to the power xy minus cos x. This is 1 plus xy e to the power xy minus cos x. 2x sin y. This is 2x sin y. Here also it is 2x sin y. Okay. Okay. So let us discuss question number 4. How we can solve this? So we have the value of u as u is equal to x y z I cap plus x z square j cap minus y cube k cap. Okay. So let us find del u upon del y. So del u upon del y is x z I cap plus 0 j cap minus 3 y square k cap. Okay. And we have del 2 u upon del y square is equal to minus 6y k cap. Okay, so we have the value of del 2 u upon del y square is equal to minus 6y k cap. Okay. Now let us find del 2 v upon del x square. Now we have the value of v as v is equal to x cube y cap minus x y z j cap plus x square z k cap. So we have del v upon del x as 3x square I cap minus yz j cap plus 2xz k cap, and we have del 2 v upon del x square as this is 6x I cap plus 2z k cap. Okay, now we have del 2 u upon del y square cross product del 2 v upon del x square is equal to, let us place this is I j and k, and this is 0 0. This is minus 6y is the coefficient of k cap. This is minus 6y, and this is 6x. This is 0. This is 2z. These are the coefficient of del 2 v upon del x square. So this is equal to I का coefficient क्या होगा? This is 0 plus j cap. This is minus 36xy. Okay, plus k cap का 0. So this is equal to minus 36xy j cap. So the value of this is minus 36xy j cap. Okay. Now let us discuss question number 5. How we can solve this? So we have a cross b. So a cross b, let us find this. So we have I, j and k. So let us place the coefficients of a here. These are the coefficients. So we have x square yz. This is minus 2xz square. This is xz square. And we have the value of b as this is 2z, this is y, and this is minus x square. So the value of a cross b is, so a cross b is equal to I cap, this is 2x cube z square minus xy z square plus j cap, this is 2x z cube minus, this is minus minus plus, so this is x4 yz plus k cap, this is x square y square z plus 4x z cube. Okay, this is the value of a cross b. So let us find, so we have the value of del 2 upon del x del y is equal to a cross b is equal to del upon del y of del upon del x a cross b. Okay, so let us differentiate with respect to x. So del upon del x of a cross b, this is equal to I cap, this is 6x square z square minus yz square plus j cap 2z cube plus 4x cube yz plus k cap, this is 2xy square z plus 4z cube. Okay, now let us differentiate this with respect to y. So del upon del y of del upon del x a cross b is equal to I cap. With respect to y we are differentiating, this is minus z square plus j cap, this is 4x cube z plus k cap, this is 4xyz. Okay, We have to find the value at 1, 0 or 2. So let us place the value of x, y, z in this particular expression. So we have del 2 upon del x del y a cross b is equal to, let us place the values. So this is z is equal to minus 2. So this is uh, minus 4 I cap, and this is 4 into, this is 4 into 1 or minus 2. So this is 4 into 1 or minus 2, minus 8. This is minus 8 j cap. उसके बाद 4 into 1, this is 0. This is minus 4 I cap minus 8 j cap. Okay. So now let us discuss question number 6. How we can find this? So we have the expression for f as, so f is equal to 3x square y minus y cube z square. Okay. Y cube z square. So let us find the gradient of f. The gradient of f, how we can find? So del operator we have to apply. So del operator is I del upon del x plus j del upon del y plus k del upon del z. Let us apply this on the scalar. Gradient of gradient is always applied on scalar functions. So this is 3x square y minus y cube z square. Okay, so this is I cap of, this is 6xy plus j cap. This is differentiation of this particular expression with respect to y. This is 3x square minus 3y square z square plus k cap. This is minus 2y cube z. Okay, this is gradient of f. So gradient of f at 1 comma minus 2 comma minus 1. Let us place the values. This is 6 into I cap. This is 6 into 1. Value of x is 1 and y is minus 1 into minus 1 plus j cap. This is 3 minus 3 into, this is 4 into 1 plus k cap. This is minus 2 into value of y is minus 2. So this is minus 8 into value of z is minus 1. So this is equal to minus 6 I cap and j cap. This is 3 minus 4 is 12. This is minus 9 j cap. This is, it is 16. This is minus 16 k cap. Okay, sorry, this is y, value of y is minus 2 here. 6 xy है ना, तो 6 into x is 1 and y is minus 2. So this is 6 into minus 2. Okay, so this is minus 12. So this is the answer. The value of gradient of y at point 1 minus 2 or minus 1 is minus 12 I cap minus 9 j cap minus 16 k cap. Okay, let us discuss question number 7. How we can solve this? Okay, so there are total 6 parts in this. Okay, total 6 parts. So let us discuss one by one. So in the first case, we have to find the gradient of f of r is equal to f dash r into del of r. Okay, so let us find this. So let us apply the del operator on f of r. So we have del as, so del of fr is equal to I del upon del x plus j del upon del y plus k del upon del z of fr. Okay, so let us find, first we will find the partial derivative of f of r with respect to x. How we can find this? This can be written as del upon del r of fr into del r upon del x. So this is equal to f dash r into del r upon del x. Okay, so this is equal to so this we can write as summation I del upon del x f of r. So this is equal to summation I del upon del r of f of r, okay, into del r upon del x. So this is equal to summation I f dash r into del r upon del x. Okay, let us further simplify this. So we have the value of del of fr is equal to f dash r we can take out of the summation. So f dash r into summation I del upon del x of r. Okay, so summation I del upon del x is nothing but del operator. So del of fr is equal to f dash r into del of r. This is the answer for the solution of the first part. Let us discuss second part. Okay, so in the second part we have del of r is equal to 1 by r into r vector. Okay, how we can solve this? So let us apply the value of del on r. So we have I del upon del x plus j del upon del y. Del of r is equal to plus k del upon del z of on r. So this is equal to I of del r upon del x plus j del r upon del y plus k del r upon del z. Okay, so how we can find this? So we have the value of r square as x square plus y square plus z square. So we have 2r into, let us differentiate with respect to x. So 2r into del r upon del x is equal to 2x. So from here del r upon del x is equal to x upon r. We have 2r into del r upon del y is equal to 2y. So from here del r upon del y is equal to y upon r. 2r into del r upon del z is equal to 2z. So from here del r upon del z is equal to z upon r. Okay, so let us place the value here. There is I cap, this is x upon r plus j cap, this is y upon r plus k cap z upon r. So this is equal to x I cap plus y j cap plus z k cap upon r. So this is r vector upon r. So let us discuss question number, let us discuss the third part. So we have discussed second part, let us discuss third part. So in the third part we have del of fr into r vector is equal to 0. Okay, so del of fr is the value of del of fr, what we have found. So del of fr is f dash r into del of r. Okay, so del of fr is equal to f dash r into del of r. So del of fr into r vector is equal to f dash r into del of r into r vector. समझ में आ रहा है? And del of r is del of r, the value of del of r is this one, r vector upon r. This is equal to r vector upon r. So this is equal to f dash r into r vector upon r into r vector. So this is equal to f dash r upon r into r vector into r vector. So this is equal to 0. Cross product of same vector is 0. Okay, so r cross r is 0. This is the expression for del of fr cross r vector. Okay, let us discuss question number fourth part of this. Fourth part. What is given in fourth part? Del of, this is del of 1 upon r is equal to r vector upon r cube. Okay, how we can solve this? So we have from the first part we have del of gradient of fr. Gradient of fr is equal to derivative of fr with respect to r, f dash r into del of r. This is not dot product actually. This is multiply. This is del of r. Okay, so in this question number 4, we have del of 1 upon r. We have to show that del of 1 upon r is equal to, we have to show that this is minus r vector upon r cube. This we have to show. So let us consider f of r as 1 upon r. So from here f dash r is equal to minus 1 upon r square. And del of r is, from second part we have del of r is equal to r vector upon r. R vector upon r. Okay, so let us place the values. So this is del of r is r vector upon r, and f dash r is minus 1 by r square. So del of fr is equal to minus 1 by r square into, this is del of r is r vector upon r. So this is minus r vector upon r cube. समझ में आ रहा है? So this we have to show. So we have to show that del of fr is equal to minus r vector upon r cube. Okay, so this is the solution of part 4. Now we have to find part 5. Let us discuss fifth part. So what is given in fifth part? So in the fifth part we have to show that del of log of r, del of log of modulus of r is equal to r vector upon r square. Okay, so in the question it is given as modulus of r is equal to r. Okay, so del of log of modulus of r is equal to del of log r. Okay, so we have, let us consider the r vector as x I cap plus y j cap plus z k cap. So modulus of r is equal to x square plus y square plus z square का under root. So this is under root of r square is equal to r. Okay, so let us find del of log r. Del of log r is equal to I del upon del x plus j del upon del y plus k del upon del z of log r. Okay, so this is equal to, so del upon del x of log r. How we can find this? So this we can write as del upon del r of log r into del r upon del x. Okay, so this is equal to 1 upon r del r upon del x. Okay, so this is equal to I cap 1 upon r del r upon del x plus j cap 1 upon r del r upon del y plus k cap 1 upon r del r upon del z. So this is equal to 1 upon r I cap del r upon del x plus 1 upon r, sorry, 1 upon r is common, we have taken common. This is j cap del r upon del y plus k cap del r upon del z. So this is equal to 1 upon r del r upon del x is, so we have r square is equal to x square plus y square plus z square. So 2r into del r upon del x. Differentiating with respect to x, we have 2x. So from here del r upon del x is equal to x upon r. Similarly, del r upon del y is y upon r. Similarly, del r upon del z is z upon r. So let us place the values. So this is I cap into x upon r plus j cap into y upon r plus k cap into z upon r. So this is equal to 1 upon r square x I cap plus y j cap plus z k cap. So this is equal to r vector upon r. Okay, so this is the solution for the fifth part. Now let us discuss the last part, that is sixth one. This is the sixth one. Del of Rn. Sixth part is del of r to the power n is nr n minus 2 into r vector. How we can solve this? Let us solve this. So we have gradient of, we know that gradient of f of r is equal to f dash r into del of r, and del of r is equal to r vector upon r. Okay, so this is from the second part. second part of this question, part 2 of this question. Okay, part 2 से आया ना. This is del of r is r vector upon r. Let us apply this. So we have, so let f of r is equal to r to the power n. So del of fr is equal to f dash r into del of r. समझ में आ रहा है? This is not dot product. So let us find f dash r from here. F dash r is equal to nr n minus 2. Sorry, nr n minus 1. No? This is nr n minus 1. Let us place the value. So this is equal to nr n minus 1 into, और del of r क्या होगा? Gradient of r is r vector upon r. This is nr n minus 2 into r vector. This is del of fr, and fr is f of r is r to the power n. So del of r to the power n is equal to nr n minus 2 r vector. समझ में आ रहा है? Now let us discuss question number 8. How we can solve this? So we have del of integration f of u du. Okay, so this we can write as summation I del upon del x of integration fu du. Okay, so this we can write as summation I del upon del u into integration fu into du into del u upon del x. समझ में आ रहा है? So this is summation I. So differentiation of this integral with respect to u is fu. This is fu into fu du, integration, differentiation of integral fu du. This is fu into del u upon del x. Okay, so fu, function of u, f of u we can take outside. So this is f of u into summation I del u upon del x. Okay, so this is equal to fu into summation I del upon del x. This is into u. So summation I del upon del x is equal to del operator. So this is equal to fu into del of u. This is del of integral fu du. So del of integral fu du is equal to fu into del of u. This is the solution of question number 8. So now let us discuss question number 9. How we can solve this? Let us solve this. So a and b are the constant vectors. A and b are the constant vectors. So let us take, so let the a vector, let us take a vector as a1 I cap plus a2 j cap plus a3 k cap, where a1, a2 and a3 are constant. Okay, and let us take r vector as x I cap plus y j cap plus z k cap. So r dot a क्या हो जाएगा? Is equal to r dot a क्या होगा? a1x plus a2y plus a3z. ठीक है, so we have let us find gradient of r dot a is equal to del of r dot a is equal to I del upon del x plus j del upon del y plus k del upon del z of r dot a. R dot a is a1x plus a2y plus a3z. So this is equal to, so partial derivative of this whole expression with respect to x is a1 I cap plus, similarly partial derivative of this whole expression with respect to y is a2 j cap, similarly a3 k cap. So this is a vector. So gradient of r dot a is equal to a vector. समझ में आ रहा है? Now let us solve the second part. In the second part we have gradient of scalar triple product, that is r, a and b. This we can write as gradient of r dot a cross b. Okay, so since A and B are constant vector, so A cross B is also a constant vector. So using this particular expression, gradient of R dot A is A. So this is equal to A cross B. This is constant. Okay, so let us take this as a C vector. Okay, let us take A cross B as C vector. So this gets transformed to gradient of R dot C. Okay, so using this expression, this is equal to C, and C is equal to C vector is A cross B. Answer. Okay, so let us discuss question number 10. How we can solve this? So we have the value of phi as phi is equal to x square y plus y square x plus z square. So del of phi is equal to I del upon del x plus j del upon del y plus k del upon del z of this is x square y plus y square x plus z square. So this is equal to, so differentiation of this whole expression with respect to x. So I cap, coefficient of I cap is, this is 2xy plus y square plus j cap. Differentiation of this whole expression with respect to y partially. So this is keeping x and z as constant. So this is x square plus 2xy plus k cap. K cap का the differentiation of whole expression with respect to z. This is 2z. Okay, so this is del of phi. So del of phi at point 1 comma 1 comma 1. This is equal to I cap. This is 2 plus 1. This is 3 plus j cap. This is 3 plus 2k cap. Okay, so this is equal to 3 I cap plus 3 j cap plus 2k cap. Okay, let us discuss question number 11. How we can solve this? This is similar to question number 10. Okay, this is similar to question number 10, and the answer of this is 7 I cap minus 3 j cap plus 4k cap. Okay, let us discuss question number 12. How we can solve this? कैसे करोगे इसको? So we have the value of u as x plus y plus z, v as x square plus y square plus z square, and w as yz plus zx plus xy. So let us find the value of gradient of u, gradient of v, and gradient of w. So let us find gradient of u. Gradient of u क्या हो जाएगा? Del of u is equal to I del upon del x plus j del upon del y plus k del upon del z. Gradient of x plus y plus z, so this is equal to I cap plus j cap plus k cap. Similarly, gradient of v क्या हो जाएगा? Gradient of v हो जाएगा तुम्हारा 2x I cap plus 2y j cap. टू वाई जे कैप प्लस 2z k cap. Okay, similarly, gradient of w is equal to z plus y I cap plus differentiation of this with respect to y. So with respect to y, this is z plus x j cap plus differentiation of whole with respect to z. This is x plus y k cap. Okay, so we have the value of this is nothing but gradient of u dot gradient of v cross gradient of w. This is nothing but scalar triple product. This we can write as gradient of u, gradient of v, gradient of w. Okay, so this is nothing but coefficients of all these in a determinant form. Okay, so we have let us write down the coefficients. So gradient of u, gradient of v, and gradient of w. This is the scalar triple product. So this is equal to, so gradient of u is I, j, and k. So this is the coefficients are 1. So gradient of u is I cap plus j cap plus k cap. So let us write down the coefficients 1, 1, and 1. Gradient of v is 2x I cap. This is 2x I cap plus 2y j cap plus 2z k cap. The coefficients are 2x, 2y and 2z. Let us write down the gradient of w. The gradient of w is y plus z I cap plus z plus x j cap plus x plus y k cap. So this is y plus z, this is z plus x, this is x plus y. Okay, so this is equal to, let us apply the row transformation. So from here we have R2, let us take 2 outside first. This is equal to, let us take 2 outside. So this is equal to 2 times of, this is 1, 1 and 1. This is x, y and z. This is y plus z, z plus x, this is x plus y. So let us take the row transformation. R2, R2 plus R3. So this is equal to, this whole expression is equal to 2 times of 1, 1 and 1. This is x plus y plus z. This is x plus y plus z. This is x plus y plus z. And this is y plus z. This is z plus x. And this is x plus y. This is equal to this x plus y plus z. We can take out the 2 times of x plus y plus z into 1, 1 and 1. And this is 1, 1 and 1. This is y plus z, x plus z, and this is x plus y. So determinant in which 2 rows are same, so the value of this is 0. Okay, so in the question it is given that gradient of the scalar triple product, the value of a scalar triple product is 0. Okay, so let us discuss question number 13, how we can solve this. So if the value of f is given by this particular expression, then prove that f is equal to r cross del of f. कैसे करोगे इसको? Solution. Okay, so let us find del of f. So del of f is equal to I del upon del x plus j del upon del y plus k del upon del z of f. Okay, so this is equal to I del f upon del x plus j del f upon del y plus k del f upon del z. Okay, so this is del f, and value of r is x I cap plus y j cap plus z k cap. Okay, so in the first part we have to show f is equal to r cross del f. So this is equal to r cross del f. So x is, the value of r is this one, and value of del f is this one. Let us place the value. So we have this as I, j and k. This is x, y and z, and del of f is, del of f की value क्या है? Del of f is del f upon del x. Del of f is del f upon del x I cap plus del f upon del y j cap plus del f upon del z k cap. So this is del f upon del x, this is del f upon del y, and this is del f upon del z. So this is equal to I times of, let us cross multiply. This is y del f upon del z minus z del f upon del y plus j cap. This is z del f upon del x minus x del f upon del z plus k cap. This is x del f upon del y, x del f upon del y minus y del f upon del x. Okay, this is the value of f. So f is equal to r cross del. Okay, so this is, in the question it is given as this particular expression, this whole expression is f. So this is equal to f. This is basically capital F. So r cross f, r cross del f we have calculated, and this is equal to this particular expression, and this particular expression is f. Okay, let us solve the second part. What is asked in the question, second part is f dot r is equal to f dot r vector. F dot r vector is 0, and f vector is this one. कैसे करोगे इसको? In the second pass we have to show f dot r is equal to 0, and f की वैल्यू क्या है? f is equal to r cross del f. So f dot r vector is equal to r cross del f dot r vector. So this is equal to r vector dot r cross del f. This is the scalar triple product. So this is r vector or del f. Okay, sorry, this is scalar triple product. Okay, so the value of a scalar triple product in which two vectors are same is 0. This is equal to 0 because it is a scalar triple product, a scalar triple product with two vectors as same. ठीक है, तो f dot r is equal to 0. Now f dot del f is equal to 0 in the third part. In the third part we have to show f dot del f is equal to 0. ये कैसे करोगे? So the value of f is r cross del f. Let us apply the concept of scalar triple product. So in the third part we have f dot del f. So this is equal to r cross del f dot del f. So this we can write as del f dot r cross del f. This is also a scalar triple product. So this is del f, this is r, and this is del f. This is equal to 0. Similarly, the explanation is same, because scalar triple product with two vectors as same is 0. This is equal to 0. Okay, so we have discussed all the three parts. So let us discuss question number 14. How we can solve this? So we have to prove that A dot del of 1 upon r is equal to minus a r vector upon r cube. Okay, so let us find this. So we know that del of f of r is equal to f dash r into del of r, and del of r is equal to r vector upon r. So this we can write as f dash r into r vector upon r. So let f of r is equal to 1 upon r. So from here f dash r is equal to minus 1 by r square. So from here we have del of 1 upon r. So let us place fr is equal to 1 upon r. So this is equal to, and f dash r is minus 1 by r square into r vector upon r. This is equal to minus r vector upon r cube. So a dot del 1 upon r is equal to, the del 1 upon r is this particular expression. So this is a dot minus r cube upon, sorry, minus r vector upon r cube. So this is equal to minus a dot r vector upon r cube. Answer. Let us discuss question number 15. How we can solve this? So similarly, so we have del of fr is equal to f dash r into del of r. So this is equal to, del of r is r vector upon r. So this is f dash r into r vector upon r. So let f of r is equal to r to the power minus 3. So f dash r will be f of r. Let us consider f of r as r to the power minus 3. So f of the r is, f dash r is minus 3 r minus 4. Okay. So let us place the value here. So here we have del of fr. Del of fr is equal to del of r minus 3. This is equal to f dash r into del r. So this is f dash r into r vector upon r. So f dash r का वैल्यू ये है. This is minus 3 r minus 4 into r vector upon r. So this is equal to minus 3 r to the power minus 5 r vector. Let us discuss question number 16. How we can solve this? So we have this as del of phi dot dr. Okay, so del of phi is equal to I del phi upon del x plus j del phi upon del y plus k del phi upon del z, and dr vector is dx I cap plus dy j cap plus dz k cap. Let us take the dot product. Del phi dot dr is equal to del phi upon del x into dx plus del phi upon del y into dy plus del phi upon del z into dz. This is nothing but the total differentiation of phi. Total differentiation of phi. Total differentiation of phi. This is d phi. Okay. Let us discuss question number 17. How we can solve this? So we have to show that d phi upon ds is equal to del phi into dr upon ds. कैसे करोगे इसको? So del of phi is equal to del phi upon del x I cap plus del phi upon del y into j cap plus del phi upon del z into k cap. कैसे करोगे? Phi is a function of x, y, z. And dr upon ds is d upon dx of r vector is x I cap. Let us consider r vector. So in the question it is given as r vector is. So let us place the value of r vector y j cap plus z k cap. This is equal to dx. Sorry, this is dr upon ds है ना, तो ये ds होगा. This is dx upon ds I cap plus dy upon ds j cap plus dz upon ds k cap. Let us take the dot product del of phi dot dr upon ds. This is equal to del phi upon del x into dx upon ds plus del phi upon del y into dy upon ds plus del phi upon del z into dz upon ds. Okay, this is nothing but total differentiation of phi with respect to ds. Okay, let us discuss question number 18. How we can solve this? So del of rho is equal to um, del rho upon del x I cap plus del rho upon del y j cap plus del rho upon del z k cap. Okay, and rho is a function of p. Okay, rho is equal to function of p. This we can write as d rho upon dp into del p upon del del x I cap plus d rho upon dp into del p upon del y j cap plus d rho upon dp into del p upon del z k cap. So let us take d rho upon dp outside. So this is I cap del p upon del x plus j cap del p upon del y plus k cap del p upon del z. This is equal to d rho upon dp into del of p. Okay. Okay, so now we can solve question number 19. So we have the value of phi as phi is equal to 3r square minus 4r 1 by 2 plus 6r to the power minus 1 by 3. Let us consider this as f of r. So we have the del of fr is equal to f dash r into r vector upon r. Okay, so we have let us consider this. So we have consider f of r as this one. So f dash r की वैल्यू क्या हो जाएगी? F dash r, this is 6r minus 2r, this is 2r or minus 1 by 2 minus 2r minus 4 by 3 into r vector upon r. So this is equal to 6 minus 2 r minus 3 by 2 minus 2 r minus 7 by 3 into r vector, and this is equal to 2 times of 3 minus r minus 3 by 2 minus r minus 7 by 3 r vector. This is del of phi. Let us discuss question number 20. This is the last question. Interpret the symbol a dot del. ठीक है, तो let us consider a as a vector as a1 I cap plus a2 j cap plus a3 k cap. del को कैसे लिख सकते हैं? I del upon del x plus j del upon del y plus k del upon del z. तो a dot del इसकी वैल्यू क्या हो जाएगी? This is a1 del upon del x plus a2 del upon del y plus a3 del upon del z. So this is equal to a dot del. अब देखो, in the second part we have to find a dot del into phi. So this is equal to a1 del phi upon del x. Just multiply this with phi. Okay, multiply this with phi. This is a1 del phi upon del x plus a2 del phi upon del y plus a3 del phi upon del z. So this is equal to, so this we can write as dot product of a1 I cap plus a2 j cap plus a3 k cap dot del phi upon del x I cap plus del phi upon del y j cap plus del phi upon del z k cap. So this is equal to a dot del phi. समझ में आ रहा है? Now in the third part we have to show a dot del into r. Okay, so a dot del, तो a dot del की वैल्यू a1 del upon del x plus a2 del upon del y plus a3 del upon del z into r vector. ठीक है, r vector is x x I cap plus y j cap plus z k cap. So this is equal to, this is a1 I cap plus a2 j cap plus a3 k cap. This is a vector. Okay, so we have discussed all the 20 questions. Okay, all the 20 questions. So we have, let us summarize what we have discussed. So these are our micro topics. Okay, so we have discussed up to, so we have discussed up to problems on the gradient. Okay, so in the next lecture we will start discussing divergence of vector point function. After that we will move on the further topics in this particular manner. Okay, thank you.